In this lesson, we'll look at how to find an equation from a table of values, how to know whether it's an exponential function or not, and then how to find the equation of that. So if you remember from grade 9, when we had a table of values, we looked at the finite differences, or the first differences, and we looked at whether subtracting the y values would give you a constant value, and that would tell you whether it was linear or not. So if the first differences were the same, then we knew it was linear. And if the second differences were the same, which you did in grade 10, you knew it was a quadratic function. If we have a table of values and the division of the y values gives us a common value, then that determines whether it is exponential. So looking at this table, I know that if I subtracted -2 minus -1, I'd get -1. And then if I subtracted -4 minus -2, I would get -2. Because these first differences are not the same, I know it's not linear. So that tells me it's not linear because the first differences are not the same. If I did it again, I would see that it's not quadratic because the second differences aren't the same. So what we have done here is we have divided the y values. So if we divide -2 by the term before it, -1, we get +2. If we divide -4 by the term before it, we get +2. And so that we can see when we divide a y value by the y value before it, we get a common ratio. So that tells me it's exponential. And so the first question is it exponential? Yes, it is. I have a common ratio. What is the starting point? So here's the starting point. When x is 1, y is -1. So that's my a value. The common ratio we determined to be 2. And so now we have an equation. Y equals, remember our exponentials are always ab to the power x, where a is the starting amount and b is the common ratio. So I know the starting value is -1. I know the common ratio is 2. I can find an equation. So let's look at this one. Looking at it, I know that the first differences are not the same, so I know it's not linear. So let's see if there's a common ratio. So we'll do 10 divided by the term before it, which is 5/2. We'll do 25 divided by the term before it, which is 5/2. We'll do 62.5 divided by the term before it, which is 5/2. So I get that common ratio. If this is the same, then it is exponential. The common ratio is 5/2, or if you want to use a decimal, 2.5. The starting value is here. When x is 1, y is 4, so that's my starting value. And so my equation would be starting at 4, we have a common ratio of 5/2 to the power x, or if you want to use a decimal, 2.5 to the power x. Okay, let's look at this one. So we're going to do 27 divided by the term before it. That reduces to 1/3. 9 divided by the term before it reduces to 1/3. 3 divided by the term before it reduces to 1/3, and then 1/3. So we do have a common ratio. It is exponential because we have the same common ratio, the common ratio being 1/3. Starting amount is here at 81. So the equation is starting at 81, common ratio of 1/3 to the power x.